Hi everyone, this is Adam again. So I'm just going to finish up on the functions chapter tonight with the transformations and the different whether things are bijective, injective, and so on. Okay. So first of all, how can you transform a function? You can multiply it by something, or you can add something to the x value and then something will happen, okay? So, if we start off with lines, if I start off with the y equals x line, if I multiply that by a half, I get a line, so I might actually do different colors for this, that might be the best idea. If I multiply it by, say, a third, so y equals x over 3, or I multiply it by, say, 2, so y equals 2x, all that happens is that the steepness of the graph changes. Okay, so if you multiply it by 2, it gets steeper. If you multiply it by a third, it gets less steep. Okay, that obviously coming from the y equals mx plus c. So obviously if you multiply the whole thing by 3, then obviously m will get bigger and therefore it'll get steeper. Let's say it's y equals x plus 1, like this. You can also add stuff to it. If you add 3, it just gets 3 higher. So if it's y equals x plus 3 instead, and then if you minus, say y equals x minus 5, it just gets lower. So here, this is 6 lower because 1 to minus 5 is 6, and then 1 to 3 is 2. So it's just shifted up by 2. So that's how you deal with linear graphs, or transformations of linear graphs, okay? So the next thing is to do quadratics. So if you have some quadratic like this, and you do y equals x squared, you'll get something that looks like this. Now, if I do, say y equals a half x squared, so again, the slope of the graph has become less, so it's less steep and therefore it kind of bottoms out, if that makes sense. And then the opposite effect is observed if you say you multiply it by 3. It just gets much, much steeper. Okay, so not too bad. And then let's say you multiply it by a minus, then it just flips the other way. Yeah, so y equals minus x squared, just like that. Just flips to the other side. If you multiply it by a minus, it just gets flipped from the top to the bottom, okay? And from the bottom to the top. Okay, now, again, you can also raise it. I'll just do this quickly. If you do the y equals x squared graph, and then say you add 2, then it just goes up by 2. So y equals x squared plus 2, where this distance here is always equal to 2. Okay, so you're just quite literally just shifting it up by 2, always, okay? Now, the hardest one is when it starts moving to the left and to the right. So if I do y equals x squared, like this, now, if I wanted to draw y equals x minus 3 to p squared, just again, you can pause the video and just think, where does that go? The answer is it actually moves to the right. So you might think, your intuition might tell you that it moves, that it should go left, but it doesn't. It actually goes to the right. The reason for this is that if you ask when is x squared equal to 0, well, the answer is when x equals 0. Grand. But if I asked you when is x minus 3 squared equal to 0, the answer is x equals 3. Okay, so the 0 point, so here, this has been moved over here. So this has just been dragged to the right by 3 units. So when you minus, you go to the right, and then the same thing. If you add, you go to the left. So say this is y squared, y equals x plus 4 to be squared, where this is going to be minus 4. Okay? So here, this is 3, and that over there is minus 4. So that's the main thing to know, that if you add, you go to the left. If you minus, you go to the right. Okay? And that is kind of it, because all those rules will still apply to something like a cubic. Okay, so if you have a cubic, so y equals x cubed, it'll look like this. Again, if you multiply it by 2, it'll just get a bit steeper. So if that's y equals 2x squared, cubed, sorry. And if you add stuff to it, it'll just be moved up like this. That would be the y equals x cubed plus 2. Again, where this distance is just 2. And then you'd also have, if you moved it, so if you moved it off over here, this would be the y equals x minus 3 cubed. Again, where this is 3. Okay? So that's your cubics. So that's your cubics, and that's fine. Then your exponential ones are the exact same. So let's look at something like this, where it's e to the x. It'll look something like this. Again, if you multiply it by 2, all the values will just be multiplied by 2. So if y equals 2 e to the x, again, it'll move to the right if you do y equals e to the x minus 2. So now just be careful. This distance here is 2. And there's a 2 up here. So again, this is very, very important. This x minus 2 up here. Okay, so whenever you minus, it'll move to the right. And then if you add, it'll move back to the left. Okay? And again, you'll get something like this. If you said y equals e to the x minus, sorry, just be very careful. This is minus 10. So you do e to the x first, and then you minus 10 after it. Okay, so I'm not doing the power, where that distance there is 10. Okay? All right, so that would be how you do an exponential function. And then a logarithmic function would be the exact same thing. Okay? So I might just do the logs, and then I think I might leave it at that. So a log graph again. You would have something that, sorry. Again, logs typically only live on the right hand side. So I can just do this instead, just to make it a bit easier to draw. So if I did this, say that was log to the base 2 of x. If I add 1, it'll move to the left by 1. Where this would be y equals log to the base 2 of x plus 1. Okay, so again, if you add it, it'll move to the left. And then if you minus, or if you multiply it by 2, it'll just get a little bit steeper. So all these values are multiplied by 2. 2 log 2 of x equals y. Okay? Alright, so I think I will leave that there for today. So thank you very much for paying attention, and yep, I'll see you in the next video. Bye.